Welcome back, YouTube. Here we go again, 2017 AB2, but this time Pythonically, using a Jupyter notebook on cocalc.com, otherwise known as Sage Math Cloud or cloud.sagemath.com. So, let's start. Come on. So, let's make a Jupyter notebook. It's a new file. I already have it done here, but that was just me experimenting with stuff, so ignore that. Let's see, I have an AB2 Sage. I don't have an AB2 Python, right? So ignore these two. Okay, so new. All right, it's going to be 2017 B2 Python. Pythonically or with a Jupyter notebook. So let's make a Jupyter notebook. There it is. Loading, loading, loading. Okay, there you go. Alright, so let's make a comment. What we're doing. Well, usually I put my name on here. Well, whatever. What we're doing. 2017 AB2. And they give you some initial information. Initial amount of bananas is 50 pounds at t equals 0 hours. Alrighty. Now we're gonna use a function f of t and g of t, as you saw a minute ago, and as you've seen in the other videos, just for fun. Here it is. So f of t is the rate at which customers remove bananas from a table from 0 to 12 hours. The store opens at 0 hour, whatever that is. And f of t is measured in pounds per hour, and t is measured in hours. And then this g of t is how fast the employees are putting more bananas on the table in pounds per hour. G is in pounds per hour and t is in hours. Starting at the 3rd hour after the store is open. Okay, so first we have to see how many bananas have been removed in the first 2 hours. Okay, so that's where we're going to start. So what does that mean? Well, we have to define our functions, right? Now, in standard Python, if you need the sine function or log function, you have to import it. So from math, import sine and log. Log is really log base e or ln. Okay, so now we can define f of t. Whoops. As returning, now this is what they gave us, 10 plus 0.8 times t times the sine of t cubed, and this is how you do exponents in Python, over 100. Alrighty. And that's all there is to that. And g of t goes like this. G of t returns, and what is it? It's 3 plus 2.4, 3 plus 2.4 times the log, again base e log, of t squared, again you can't use caret here, this is not basic, plus 2t, and be careful, multiplication is explicit. Okay, or it needs to be rendered explicitly. There you go. Alright, so here's 2a. Now in 2a, I think the answer was about 20.051 pounds of bananas are removed from t equals 0 hours to t equals 2 hours. Now let's see if that's true. What we did was we did a Riemann sum. We let a equal to 0 and b equal to 2. Alright, then we did a loop to do like a convergence table for x in range 5. And what does that do? It generates x values 0, 1, 2, 3, 4. Okay, and I get their integers, okay? So what am I doing with that? Well, I'm going to use that to find the number of rectangles. The number of rectangles in my Riemann sum is going to be 10 to the x. So when x is 4, that's 10,000. When x is 0, that's just 1, right? So it's going to get lots and lots and lots of rectangles. See if we get convergence out of this. Let h, the base of each rectangle, or the height of the trapezoid, is really a trapezoidal sum I'm doing here, is quantity b minus a over n. Okay, there you go. Then we did a list comprehension to find the left sum. So let the left sum equal the sum of the list made up of all the areas. F of a plus I times h, right? So a is the left side and I is 0. We're doing f of a for the first rectangle height. And don't forget times h for the base of the rectangle. Okay, and then the next rectangle height will be at a plus I times h. So if I is 1, it's going to be a plus h, or h is, where h is delta x, is going to be the next left side of the next rectangle, and so forth. All right, so those are all the, that's the list or sequence of numbers that I'm going to add up for I in range, let's make it n. All right, so if n is 10,000 rectangles, it's going to do that for 10,000 rectangles, and the list will have 10,000 members in it. It's like, it's a sequence, like sequences in series, and the sum is the series. Okay, and so these list operations are really at the heart of Python. It's really nice when you're doing sequences and series in Python. Okay, so now what's the right sum? Well, the right sum is the same, except it's the same as the left sum minus the first rectangle, f of a times h, the area of the first rectangle, plus the rightmost rectangle that wasn't used in the left sum. There it is. And then what we're going to do is we're going to print quantity L plus R over 2, which is the trapezoidal approximation, which would be the closest approximation. So if I do Control Enter, we have a big error already. Okay, so there's two issues going on here. Notice in the top right hand corner, and I messed this up this is actually a re-recording of this video. I didn't realize that this defaults to Python 2, where 0 is treated as an integer, and we're doing integer division, and 2 is treated as an integer, right? So one way around this is to put 0.0, 0. So in other words, it's not going to do div and mod, it's going to do regular decimal division, right? Let's see if that helps. Control Enter. So all the input constants that need to be floats, you got to make them floats. Another way to do it, of course, is to say, all right, cast it to a float. You can do this, right? But apparently the preferred way to do this, I'm doing a little research on this, if you don't have Python 3 running in your Jupyter notebook, is to just leave it the way I had it. But let's import, let's see, so from future version of Python, in other words Python 3, future, which exists on here apparently, import division, import division. So from now on, when this problem comes up, it's actually not going to be a problem. So there's my answer, 20.051 pounds, more or less. Okay, so we got the answer, and we figured out this problem with the future version of division in the Python 2 issue. Okay, so there you go. And so that's why I'm using print and not print method. Yeah, I missed that little detail last time. Okay, let's do 2b. Now what's 2b? Let's see, this is 2b, where are you? 2b. Find f prime at 7 using correct units. Explain the meaning of f prime at 7. Well, f is in pounds per hour. F prime at 7 is in pounds per hour per hour. It's sort of like an acceleration. So it's how fast the rate of change of the bananas is changing at 7 hours into the day of the store. So let's do that. And here we go. So let's make a little comment, just see what we're doing. Comment, note to self, 2b. I'm just going to write down the answer that we got. The rate of the bananas being removed at, rate bananas, I can't spell, removed at t equals 7 hours is decreasing 8.120 pounds per hour. And I'm going to write it this way. Or to be Pythonic, maybe this way. Okay? There you go. So let's figure out how you do that. Well, what we're going to do is we're going to define our own derivative function. Define diff, as it's called in Sage. This will be my own diff. At a particular point with an x value x, and for a particular h, we're going to do the difference quotient limit. So we're going to return, let's see what we're going to return. We're going to return quantity f of x plus h minus f of x all over h. There you go. And what we're going to do is going to do another convergence table. So how about this? For x in range 5, and if 5 is not enough, we'll make it 6, and if 5 is too much, we'll make it 4. And let's see if we get the convergence that we want. We're going to print the diff of 7 comma, how about 10 to the negative x. I think it does a negative first, so you don't need parentheses around the negative x. If it doesn't work, we'll fix that. And again, there was a problem here. If you don't put 7.0 or float 7, you got wacky results. But since we imported from future, we imported division, this should not be an issue. And so let's run it. And it is an issue. What happened? From future import division, right? Wait. So I ran that here. And I'm running it here. There it goes. Okay. Somehow I didn't see the first cell. All right. And yeah, it's decreasing at a rate. That's why it's a negative. 8.120-ish if we round off the 3 places. Pounds per hour. There you go. Perfect. Very nice. All right. What's part C? Let's see. Part C over here. Is the number of pounds of bananas on display table increasing or decreasing at t equals 5? Give a reason. Well, remember that f of t is how fast the bananas are being removed in pounds per hour, and g of t is how fast they're being replaced in pounds per hour. So I need g of 5 minus f of 5 in pounds per hour, and let's see if that's correct. Let's go. Let's see what we got. So let's go back to our Jupyter notebook. Just a moment here. Do I have something in here? Oh yeah, I have all the results here that we had from when we did it on the T84. All right, so we got this, we're going to get this hopefully right now, and we're going to get this finally at the end. Okay, good. All right, just checking my work. And so 2C, here we go. So let's make a new cell. And let's see, so comment 2C. I got rate banana, where was it? Bananas decrease, bananas decrease, I can't spell today, decrease 2.263 pounds per hour at t equals 5. Alrighty. And let's see, let's be consistent here. I'm not putting spaces between constants and units, so that's confusing now. That's hard to read like that. I'm gonna write it like that. Okay. All right. So what are we gonna do? We're gonna print g of 5 minus f of 5, and what do you get? And is it negative 2.263-ish? Yeah, there it is. Perfect. Nice. All right. And part D. Part D, where are you? How many pounds of bananas are on display at time t equals 8 hours? All right, so remember, at the very beginning, it says we're starting with 50 pounds of bananas, right? Then f of t, we're removing bananas for the entire 12 hours, but g of t, we're only adding bananas for 3 through 12, right? Through hours 3 through 12. So what are we going to do? Well, we're going to do another Riemann sum, that's all. So here we go. So 2D. Yes, can I get a new cell, please? There you go. Oh, too many cells, whatever. All right, so comment 2D. All right, so when I did this before experimenting, I got about 23.347 pounds on the table at t equals 8 hours. Okay, how do we do that? Well, let's first of all, let's initialize the amount of bananas we have to 50. And let's print out what we got so far. So print, quote, pounds equals, how about this, like this, okay, comma, pounds, comma, quote, at t equals 8 hours. All right, and then let's put another print over here to separate that output from anything else, and that's all it does. All right, there you go. Pounds equals 50. Oh, too much spacing. All right, it puts a space in front of the literal constant answer there, right? So, all right, so, and I might as well put little units here. There you go. Okay, good. All right, so now we're gonna take away, for the first 3 hours, we're gonna take away the area under f of t from 0 to 3, right? So let's do, let's say A starts at 0, and B is 3, and that's hours, right? And then we're going to do our Riemann something again. So for x in range, I guess I could just cut and paste. Should I cut and paste this? Okay, let's cut and paste. Where was the last time we did this? Let's just cut and paste this whole thing. Can I? There you go. Well, copy, not cut. All right, let's going to put it right here. There you go. All right, so it's going to figure that out. Okay, so if we just run that, see if we get a convergence. We're about 30.386, let's say, pounds of bananas have been removed in the first 3 hours. What I want to do is I want to subtract that from pounds, right? So let's do this. Pounds minus equals that number, that last output. And then we'll just copy all of this again. Let's put it right here. And let's see what you get. Okay, maybe I should put another print here. Well, even here. Yeah, I'm not in this in the loop. Just separating out the outputs, it's easy to see. Okay, so now we're down to 19.613 pounds of bananas at t equals 8 hours? No. Oh, this is 0 hours here. And where did I get 8 from? And this is 3 hours here. Aha. Just debugging as we go. Yay. And good. Nice. I like it. All right, so now what are we going to do from hour 3 to hour 12? Well, we're going to do something similar. Okay, so how about, all right, let me copy this. Yeah, this whole thing. Let's put it here. But what we're going to do is we're going to add this amount, whether it's positive or negative. That's how much we're gaining or losing. And it's not f, it's f minus g, right? So what am I going to do with that? How about if I change, all right, let me change the function then. So I'm not going to go from 0 to 3, I did that right. I'm going to go from 3 to 8. But I'm going to change my function. I'm going to say, how about define my function? Whoops, camel case. To return what we're gaining, g of t, minus what we're losing, f of t. And all right, so where's g of t? G of t is way up here. All right, so, well, since I'm calling it my f, can I just do g of t minus f of t and be done? Let's see if that works. I did it more complicated last time, but all right, so let's make it g Well, everything's in terms of t, huh? All right, so g of t minus f of t in terms of t. Right, and then we're going to make this my f. All right, so wherever in the loop I have f, I'm going to have my f instead. So my f, camel case, and my f. So this is the function we're finding the trapezoidal area under it. And is that it? Well, let's find out. And yeah, that's it. Okay, so this is how much. This is how much we started with 50. Then f of t from 0 to 3 hours is all that's working, not g of t. We're losing this much, so we're down to this. But then from 3 to 12 hours, g and f are working against each other, and we're gaining 3.734 bananas for a total of 23.347 pounds of bananas at hour 8. Well, let's fix that at hour 8. I think we're good. And that's it. That's what we selected, right? 23, where did I put that? 23.347 pounds at hour... Oh, that's where I got messed up. Wait. Hello. What's going on here? What's the output? Yeah, I'm still messed this up. I need 8 here, because that's the final answer. I need 0 here, because that's where we're starting. Whoopsie. I messed up what I was doing. Let's see what that looks like. So 50 pounds at hour 0, 19.613-ish at hour 3, and 23.347 at hour pounds at hour 8. Good, that's nice, perfect. So there's how you do 2D, there's how you do 2C, there's how you do 2B, and there's how you do 2A, Pythonically in a Jupyter notebook on cocalc.math. And I think we're done. So thanks for watching, hope that helps. Bye-bye, YouTube.